talk about banked curves and the force diagrams for banked curves. They are the hardest. The easy part is the force of gravity. This is, you gotta show these with two pictures because you want to look at them both from the side and top down. So top down, the force of gravity kind of goes into the page. We're not going to show that. The side view, this is like literally a slice of the tube. I tried to draw my tube. Gravity goes straight down, and that's just the weight. I can get that by measuring the mass and multiplying by the acceleration due to gravity. In my case, it's 0.05 newtons. Then there are going to be some different normal forces. One, you can show on the side view, it's going to be up, it's going to be whatever, it's going to be perpendicular to whatever angle the thing is running at. And that's a normal force. And finding that normal force is a little tricky, and we're not going to do it first. The easy one to find out is the normal force for the top-down view, which is really the piece of this normal force, I'm going to call it A, in the into the circle direction. And I imagine you can figure out that the piece of this normal force, I'm going to call it B, straight up and down, has to match the gravity. Unless you have a banked curve that's going down as well, and I'm not going to talk about that in general. I'll just talk about it with you if you come to me and talk about it. So this piece of this normal force is going to equal whatever your weight is. Let's talk about this piece. Here again I have a circle. I have only one force into the center of the circle, so I want to use my net force in the centripetal direction equals mass times my centripetal acceleration. From your energy calculations, you should know what the velocity is here. You take the velocity, square it, divide by the imaginary radius of this banked curve, and this normal force, this piece A, I'm going to call it A, is really the only centripetal force. So that's just going to equal mv squared over r. So now I know that B is Fg, these are the same, and A is mv squared over r. And I've got two pieces of the triangle, and you know how to put those two pieces together with Pythagorean theorem and find the actual normal force. If you want to find the angle, you can also use trigonometry. The tangent of the angle is equal to the B piece, which is mg, over the A piece, which is mv squared over r. The m's cancel, and I just get rg over v squared. I want to take the tan minus 1 of that to get the angle. So that, for those people who can do trig, should be very doable.